So let's talk about MongoDB. So MongoDB is one of many databases that fall in the umbrella of NoSQL databases. Okay? Certainly, we've been using up to this point relational databases that split up their content in multiple tables and records, and usually those records refer to each other using foreign keys, primary keys, and whatnot. So there's certainly multiple ways of storing structured data, and non-relational databases is basically what the name suggests. We're not going to use tables. We're not going to use records that refer to one another. They're not going to be related. MongoDB is better to think about it as a object store, right? That allows you to store object instances in a database and then retrieve them by using criteria in a query language that allows you to say, oh, I want those objects that meet a particular criteria, right? Very much like having object instances in memory and then storing it temporarily in database and then retrieving them at some later time. So MongoDB is great. I'm not going to go into the details. There's plenty more in a relational database or in a database course. We're going to just skim the surface of using MongoDB enough to be dangerous. If you go to MongoDB website, they'll try to sell you the MongoDB Atlas and hosted services and whatnot. There's no need to do that. There's the community server or community edition. It allows you to use a free download of their database, and which I already had installed it. When you install it, there'll be two executables of interest, right? That you'll care about. One of them is the server itself, the Mongo daemon that starts the server, and the other is the Mongo client that allows you to connect to a database and start interacting with it. Also, one of the things that you'll need to configure is that at the root of your file system, you'll need to list the data. You'll need to create a directory called data /data, and under there another directory called db. Okay, so this directory is where MongoDB is going to store all its files, all its databases. All right, and in there's 143. No, I don't want to see them. So there's a lot of databases in there. Indices are stored in here. Any collections that you've created are stored in here. Okay. And so let's play around with this. Let's start the server. If I haven't already, I'd forget. I might have it already installed, running. MongoD. Oops. Looks like it's already started. Yeah, shutting down because it's already started. So once it starts listening at a particular port. I think it's 27017, something like that. It also looks for that directory. If it doesn't find that directory, it's going to complain and say, where you want me to put my files, right? Both of them are obviously configurable. You can change the port. You can put the directory where it goes. So let's connect to it. There. So we're in the database, and we can start interacting, doing things such as listing existing databases. So we can say show DBs. Right now I have these databases here, and you can create a new database very easily by using the use command. So just something like use. Let's create a whiteboard for CS5610 fall 2018. Right. Once you create it, the database exists, and you can start interacting with it. Here's where you would store your tables, your records, whatnot. But we don't call them records. We don't call them tables in Mongo. We instead call them collections. Right. So instead of table, we say collections. Instead of records, we say documents. Right. Right now we don't have any collections here. We can show the collections and there are none in there. Right? There's nothing in there. So let's create our very first collection. Maybe students. We've been playing around with students. Let's create a collection that contains students. So we'll say to create collections or interact with anything in the database, all commands start with DB. Everything starts with a DB, followed by the collection that you want to interact with. Right. So in this case, the collection might be student, but you might say, wait, but there are no collections. How are you going to interact with a collection that doesn't exist? Actually, the collection is created on the fly when you start inserting and interacting with it. Another thing you might say, well, when you create these collections, just like when you create a table, typically you have to describe the table and say what fields are in the table and the data types, and none of that. Right? There are no schemas in Mongo. And so if you're coming from a relational database world, you might start cringing at that. Says, what do you mean there's no schema? Schemas play an important part in databases in validating that the structure of the data is correct, right? That if you're expecting a date, you indeed are passing a date or an integer or string or whatnot. So none of that. So the database is not going to have any of those. Is not going to be responsible for any of that. Instead, that responsibility is gonna be moved over to the application side, right? So the application side is the one who's going to be responsible for making sure that your data types are correct, the structure is correct. The database is only going to responsibility is only to make sure that things are being stored correctly and retrieved correctly, and it's fast and it's redundant and it's fault tolerant, and many other features that it's going to be its responsibilities. So anyway, so let's create our very first record document. Sorry. So db.student, that's the collection I want to create. Dot, I want to insert my very first document. So insert, and notice that the notation is very object-like, where you have dot notation, very much like JavaScript if you were interacting with some JavaScript API. So the function here is insert, and it takes as argument a JSON object. What do you want to insert? We insert JSON objects. So for instance, if this were a student, we might say username, and we're going to insert maybe Turin. Right. So let's insert Turin. Now notice that it says that indeed we were able to insert the very first student in there, and we can retrieve it. Similarly, we can say db, then the collection student, there it is. And instead of inserting, we might want to be able to retrieve data from the database. So there's a command for that too. We can say find. Find is very much like a select in a relational database. So find retrieves all the records. In this case, we only have one. Right? We have Turin. And notice that find is also a function that could take arguments. Those arguments would be for establishing predicate if you want to find a particular record. So for instance, if we had several other students in here, so Turin, Tesla, who else? Who else would we put in here? Asimov. And so now we do a find, right? It returns all three records. Also notice in here that there are some fields that we certainly didn't insert in here. There are these underscore ID fields that were added automatically by Mongo, and they look like they're associated to some unique identifier, right? And so they play the same role as a primary key would be in a relational database. But here it's created for you. You don't have to specify auto increment or anything like that. It makes sure that it's unique within that particular collection. Also notice that it has an underscore in front of it. It means that it's a field that was generated by the infrastructure, right? So it's not so that you can recognize fields that you created versus fields that are managed by the system. So excellent. We can so find allows you to retrieve all the fields. You can retrieve a particular field. I'm sorry, document. You can retrieve. You can use find. Oh, I didn't mean to do that. Show DBs. Use. Did I misspell it? Show collections. So db.student.find. There we go. You can use the same find to retrieve a particular document, right? If you can provide either the primary key to retrieve the document by ID, or you can provide a non-key attribute. So for instance, you can say, I only want the one whose username is equal to Tesla. So it returns that one document. Make sense? So it's using it as pattern matching to identify the particular field. You can also update elements or documents. You can say db.update, right? And I'm sorry, db.student.update update. And update takes two arguments. The first argument is to identify the document that you want to modify, and the second argument is what do you want to do with it, right, once you find it. So for instance, if I want to modify the document whose username is Tesla, right, and I want to change it so that I want to update it, right? Now I can replace it entirely by providing a new object, right? For instance, I could say the username is actually Nicola, right? If I do a find, notice that Tesla's no longer there. But if I do a find all of them, notice that it was completely replaced, right? If I wanted to change a field, so let's say if I want to add a field, so for instance, let's modify this. I'll change the element, the document whose username is Nicola, and I want to change maybe I want to add things to this, not replace it. I want to change a couple of things, maybe add a new field perhaps. I could say maybe we could use set. Set, notice it has a $ in front of it. That means that this is not a field, right? Like this one, for instance, username. Username is definitely a field here. But this is definitely not a field. Notice that it starts with a $. It means that that's an operator. Right? It should be interpreted as an operator. That takes a couple of arguments. Right? So the argument of all these operators typically is another JSON object. So this is another JSON object where we might say that the first name is Nicola, right? And maybe that the last name is Tesla. Okay. Right, so if we look up all the objects again, notice that indeed this was not replaced, but instead we added new fields like last name and first name. Notice that even though all these three objects live in the same collection, they don't have the same schema. See that? Some of them have some fields, some of them don't have several fields. There's no validation. There's no checking to see that all the fields have the same name, the same data types, nothing. Right? The responsibility of that will be upstream in the application layer. Okay. So we can insert, we can find, we can update, we can also remove. Right? So that for instance, let's remove Asimov from here. We can say db.student.remove, and remove takes as argument one argument. Don't worry if you do a remove and don't place any arguments. It won't actually remove the content, which is good. That would happen instead if you provide a criteria that has no parameters, right? That will remove everything. That matches everything. So it means remove everything, right? So we don't want to do that. We want to only remove the one whose the username is Asimov, Okay, so 1 was removed. If we do a find, we see that we only have 2 elements, two documents. Sometimes it's hard to read, especially if these have lots and lots of fields, right? So we can apply to finder methods. We can apply modifiers such as sorting in descent or ascending order, or you can make this pretty so that it's prettier to look at. So this is a little bit more readable, where it adds a lot of white space so that we can more easily parse this. Okay. The other thing that you can do is say that there might be dozens and dozens of fields that this might be returning, and you might only care about just a subset of those fields. Maybe you only care about the username, right? You don't really care about the first name and last name. So the finder methods can take as argument. The first one is obviously the matching, the pattern matching. For instance, let me return the one whose username is Nicola. So this says username is Nicola. So it's that one, right? But say you want to create a projection where you don't want all the fields. You only want a subset of those fields. So for instance, I only want the username. So to do that, the finder has a second argument. And the second argument is for a projection operation, where you can say which fields you want and which fields you don't want. So for instance, if I only want the username, I can specify that. I can say username 1 or true, something that is truthy. So if I do that, notice that it returns a username, but it still has a pesky a primary key in there. That way you would have to explicitly say that you don't want it. Right? That one always comes through, unless you specifically say you don't want it. So as part of this second object, the second parameter, you can say comma, any other fields you want. Right? So for instance, I might want the first name, but I don't want the underscore, the ID. I told you I don't want it. So I can say 0 or something that's false or falsy. So there it is. So I only have the username and the first name. Make sense? All right.